All right, so lesson 11.1, our last chapter. We're going to be talking about circumference, area, and volume, but we're going to add in some new things so it won't all be review. So the first part of this is just circumference. We're not going to dig too deep into it because I know that you're familiar with it. Circumference is the distance around a circle. This here just starts to relate it to perimeter as how the perimeter compares to circle. So they say it's the more sides of a polygon are created, the more our polygon starts to look like a circle, and the closer our perimeter, the closer that it approaches, the perimeter of the polygon starts to approach pi. Okay, so that's all that picture is showing, but in general we know that the distance around a circle is given to us by the formula circumference equals 2 times pi times r. R is our radius, okay? Now, because we know that a radius extended is the diameter, 2r is the same thing as the diameter. So another formula for circumference is pi times diameter. Okay, these you should be familiar with, you've seen before. So they've just written that down below here. Okay, circumference is pi times diameter, or it's 2 pi r. Now let's just use that for a little bit of practice. So part A, find the circumference of a circle with a radius of 9 centimeters. So since they're giving us radius, I'm going to do 2 pi r. I'll use that version of the formula. 2 times pi times 9 for my radius. And I can either write this as 18 pi, that would be the most exact answer. Now, if you go ahead and you round this, now if you're taking a test or ever doing anything, sometimes if they care about the decimal point value, they will specify, use the pi button, or maybe they'll say you can approximate it by multiplying by 3.14 or 22 over 7. I know in the SATs they allow that, things like that, but they'll be clear in what they want if it's going to be that precise as to how detailed they're looking. For this sake, rounding it to the 10th, I typed in the pi button. 2 times pi times 9, or 18 pi, is 56.5. We're talking here about centimeters. So if I were, basically what that means is if I had a circle, the radius was 9 centimeters. If I would then take a string and wrap it around the circle, that string, if I would measure it out from length straight, like spread it out, stretch my arms out, I would get it to be 56.5 centimeters. That's what we're finding. Okay. All right. Now part B. This one says the radius of a circle, this is what they want us to find, with a circumference of 26 meters. So again, since they're involving radius, it's easiest to use 2 pi r. You could use this version, pi times diameter, but I would prefer just to use the one that already has radius as a variable. Now they give us the circumference as 26. I don't know the radius, so I'm going to leave that as r. So when I divide this side, I'm going to divide by 2 pi. I write that in parentheses because if I just go on my calculator and type in 26 divided by 2 pi, meaning if this is my calculator screen, and I type in 26 divided by 2 pi, the calculator is only as smart as what you tell it. Any computer is. So this is going to do 26 divided by 2 and then multiply it by pi. It's going to do order of operations. So multiply and divide come together left to right, whatever appears first. So we have to remember, if you're typing it in like that, put parentheses around this. Here, obviously, that canceled. So we get r equals 26 over 2 pi. And I'll keep that in parentheses. Or you could just simplify that. 26 divided by 2 is 13. So I could also just do 13 divided by pi. Excuse me. I'm going to get the same answer either way. Okay, and that comes to be about, my radius is about 4.14, and here we're talking about meters. Okay, all right, and again, that makes sense. If I had a circle and that whole distance around was 26 meters, a radius of 4, obviously it's going to be smaller. It's equivalent. Okay, all right, so now let's add in some new stuff, shall we? We turn the page. Now we're going to talk about arc length. Okay, so the stuff we did on circles last chapter is not gone. So arc length, we know what an arc is. Now how do we find the length of it? So the arc length is a portion of the circumference. It's a portion of that distance around the circle. So we've talked about how to find the measure of an arc, like the degree value, but now we want to know how long is it. Okay, so more than just like if I were to tell you that this here is 90 degrees, yeah, the measure of arc AB is going to be 90 degrees. That's the measure of the arc. but I want to know the length of the arc, which is a little bit different, and that's what arc length is. Okay, there's no special symbol for it. They just write arc length. All right. All right, so we're going to use what we've learned to calculate that. All right, so let's scroll it down a little bit, and then we'll just practice a couple to finish up this lesson. So in a circle, let me erase that. In a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. So ratios, remember, compare values. So we have a proportion that is set up here. Okay, so let's, I don't know if you saw that my battery is running low. Let's take a look at what this is saying here. So I'm going to plug that in real quick. So just pause first. Okay. All right. So we're back. So the arc length of arc AB. So the length, and again, that would be involving units like inches, meters, feet, something like that. Okay. So a distance, that's going to compare to the entire distance around the circle known as the circumference. So this is distance, just to give you an idea of what we're working with, and this here would be distance. So these are two equivalent values of measurement. The arc length is a portion of the circumference. Now we're going to equate that to the degree values. So this is the measure of arc AB. That's what that's saying, the measure of arc AB. So that would be like, let's say this is 40. Oh, we'll go back to 90. Because that looks more like a 90-degree angle. 90 degrees. The measure of arc AB is 90 degrees, but how does that compare to the entire circle again? Which is why they put 360, because it's always 360. Okay, so I recommend memorizing this or understanding rather than memorizing this here proportion. So again, it's a portion out of the whole in terms of distance. And then they do the same thing as a portion out of the whole in terms of degrees. Okay, degree values. So that's what this formula is. Now, the way they get to this one here, the way they end up with that, didn't want that either. There we go. The way they get that is, if I go ahead and I take this here, and I multiply this side by 2 pi r. If I do it on one side of my equation, I have to do it on the other. So I'm going to multiply this side by 2 pi r. 2 pi r cancels, and I'm left with arc length of AB, which is what they have here, equals all this times 2 pi r. So this second scenario here is just a version of the one that they've already given you, which is why I said some people get stuck memorizing formulas and then it all mixes in their brain, and for starters, they don't remember it, a week, a month down the line, not to mention years. But secondly, they don't really know what they're doing. They're just plugging and chugging, and that doesn't help you learn anything. So try to understand this, and then you can create and manipulate that any way you need to based on what it is you're doing. All right, let's try some, okay? Find each indicated measure. So first they want us to find the arc length. So how long, we're talking in centimeters, how long is arc AB? Okay, so using that proportion, I'm going to say, I'm going to abbreviate, well, I'll just write it. Arc length of AB over the circumference, the entire distance around, 2 pi r. So let's calculate that. Let's see what 2 pi r is. They give me the radius of 8, so 2 pi 8. So I'm just going to write it as 16 pi right now. Okay, I'm not going to abbreviate anything for the time being or round anything. So this is my distance portion of the proportion. Now I'm going to relate it to the degree portion. So because this is a central angle, and it always will be, if this is 60 degrees in degree value, this is 60 degrees. Okay, so 60 out of the total degrees of a circle, 360. Okay, so let's go ahead and simplify it a little bit. It's going to be x over 16 pi equals, now 60 over 360, the zeros cancel, this is really just 1/6. I can multiply both sides by 16 pi. Multiply this by 16 pi. Those cancel out, and I'm left with x equals, now on my calculator I'm going to do, I can either do 1/6 times 16 pi or multiply straight across, but in the end I should get an answer of 8.38 if I round it to the nearest hundredth, which they don't say, but 8.38, and this is in centimeters. Okay, so the arc length of that little piece, and it makes sense, if the whole circumference was, this equals out to be 50.27. If the whole circumference is 50 centimeters, then just this arc being 8.38 centimeters is a logical answer. Okay. And when I say by logical, it's always good to go back and look at your work. I'm erasing this. If you needed that, just go ahead and look it back up. Like, go back in the video. But I just want to have room for what we're going to do next, because there's not a lot of space here. All right, part B. The circumference, whoa. Oh, sorry, don't know how that happened. It closed out. Did I hit the wrong button? All right, let's try letter B. Okay, so the circumference is what we want to find here. So I'm going to put the arc length, they give it to me, 4.19, whoops, centimeters, over the circumference, which I do not know, is going to equal 40 degrees, because that's the same as that arc's measure, over 360. Okay, so I can cancel these out. I can do a little simplifying and say 4.19 over c. I use c for circumference just so it stands out, and that simplifies to be 1/9. Cross multiply, so 4.19 times 9 is going to give me 37.71, and 1 times c is c, and there's my answer. Okay, so the circumference here is 37.71, and we're talking in inches. Okay, alrighty, let's move on to letter C here. In this one, they're asking us to find the measure. So again, measure is referring to what we just did last chapter, so it's the degree value. So the measure of arc RS, so that's this entire value here. All right, so when I look at this, I can see that 15.28 is marked as just the radius, okay? All right, so if I'm going to go ahead, the arc length is going to be, okay, let's actually start this one again. I was highlighting some things that were not the right interpretation. So, all right, going back. So the measure of arc RS, because it's the minor arc, they're only using 2 letters, we're going to want just this arc right here. Okay, this would have been the major arc, and we don't want that one, which makes sense that they gave us the arc length. Okay, so we want the degree value of this arc RS. If I look at that, I can say the arc length, which is 44 meters, over the circumference, which I'm going to have to calculate. Okay, so circumference is 2 times pi times r. So in this case, it's 2 times pi times 15.28. And if I multiply 15.28 times 2, I'm going to get 30.56 pi. Okay, now that's going to equal the measure of arc RS over 360. All right, so let's go ahead and just rewrite this a little bit without all of those symbols. So this turns into 44 over 30.56 pi equals, I'm going to call this x over 360. You can cross multiply. 44 times 360 is, big number, 15,840. This way I'm going to get 30.56 pi x. When I divide by 30.56 pi, again keeping in parentheses, 30.56 pi, x is equal to 30.56. I get an answer of 164.99, and that's my degree value. And that looks accurate if I think about the scenario. That this is almost 180, so 164, almost 165 degrees. Makes sense, okay? I'm going to do one more video to go over these ones for practice. If you feel like you're okay with it, you can jump into the homework though, okay? But we're out of time for this video. See you in a second if you need it. Bye-bye.